Hello guys, I hope you're all well. It's been a while since I recorded the video for you, but I'm happy that now I'm able to do one. So let's get straight to the point. So this is Venn diagrams. I'm actually not starting this video from the beginning, but then if you want a video that outlines how Venn diagrams are and how we can work with Venn diagrams, like the beginning introductions of this thing, please let me know and then I'll try to do that. So about Venn diagram, this gentleman that you see here on the top right, that's John Venn, aka the creator of Venn diagrams, let's say so. Okay, so here's a simple Venn diagram here. There are some things I wanted you to be aware of. I'm assuming that by now you already know the basics, so I just want to brush over some things. Like for instance, in this Venn diagram, I might ask you, let me put this here. On this Venn diagram, there are several things that I might ask you. I might ask you to give me certain events. And for you to give me those certain events, there are specific ways in which I can notate them, and you are supposed to give me the probability of those events. Like for instance, I can just say, let's start with this one. The probability of A and B. Remember this is an intersection. Now, before I move on with this question, I want to outline some things, some symbols. We have a symbol that outlines an intersection, right? So this is an intersection. They usually use it with the word "and". And then we have this one now, whereby it's facing upwards. This one, it's called a union. Union. The word that goes with that, it's usually "or". So key words there. So when we tell you something, when we say the intersection of B and A, we're actually looking for this part that you see right here, right there. And when we are looking for the union of A and B, we're going to say the probability of A or B. I hope that's okay, but please look at the words that I've written down there. There's an intersection, we use it with the word "and". There's a union, we use it with the word "or". So when we say give us the probability of this or that, we are looking for the union. When we say give us the probability of this and that, we are looking for the intersection. Now, in this Venn diagram that you see here, I want you to always be mindful that there are some things that are intersections. And for, in this case, this point here, this 0.1, it's the intersection of event A and B. So now, when we are looking for this, the probability of the intersection, we are actually looking at the intersection right there, where the two circles meet. That's the intersection, right? But I hope you know that at this point. So when I ask you for the intersection of A or B, you just give me the probability of that intersection. This is too light. Let me choose a darker pen. Darker pen, here we go. And then there are several things that I might ask you again. I might say to you, give me the probability of what's not an intersection. You see that I annotated this A and B, and after that I put a what looks like an exponent there. We called it, that's a prime. We say that's a prime, but there's a different word for that in this case. I'll tell you about that as we move on, but let's say that's a prime. Now, when I'm looking for that, what is not the intersection? A and B, remember, it's the intersection. So what is not the intersection? So for me, what is not the intersection? It's this 0.4. Let me highlight that. For me, what's not an intersection is this 0.4, because this value, it's definitely not an intersection. I'm also talking about the 0.3, because this is definitely not an intersection. And also this 0.2, because the intersection is the one highlighted in yellow. I hope you find. So let's do that. Oopsie. Let me remove this again. So now, for me, what is not an intersection is 0.4, as I said, plus 0.3, plus 0.2. So these values for me, they are not part of an intersection. So when I want the probability of something that is not an intersection, I'm looking for you to add this probability values for me. You're going to get 0.4 plus 0.3, that's 0.7. 0.7 plus 0.2, that's 0.9. Right there. So the answer to that, it's like that. Right. So there are further values. Like there are more values. Let me erase these details here. There are more questions that would ask you to find things like this ones. For instance, let's say they might tell you that give us the probability of what is not A. The correct word for it in probability, we call that the complement of A. So we are saying anything else that is not A, give us the probability of that. So what is that one for me now? So the complement of A is anything else that is not A. Now let me highlight that one to you. What would I mean by that? I'm saying to you now that, can you please give me the probability? Since this is A, I'm going to ignore that. But I'm looking for this because it's not A. I'm looking for that because it's not A. And I'm looking for that. So I'm talking about, wait. Let's take that back a little bit. Made a minor mistake. Anything else that is not A, the complement of A, this 0.4, it has something to do with this A there, so we don't include that one. This 0.1, this is an intersection. This is a combination of A and B. So which means now here I actually do have a bit of A in there. So I'll leave that number 2. So and then I'll focus on this number because this only works with B and it has nothing to do with A. And I'll also involve this number here. So which means now my answer for that, when I'm looking for those things, let me remove this. When I'm looking for the complement of A, I'm actually talking about the 0.3 plus the 0.2. So that should give me how much? A 0.5. Easy as that. Right? So now, another question might be, let's raise it up a bit so it becomes a bit more challenging. They might ask you to give us the complement of A, or you see the union, what is B? Now, that's a combination of 2 events now, which means what they want from you is the following. They want you to give us the probability of what is the complement of A, or they want you to give us the probability of what is B. Now, remember, when we say or, we are talking about the union. Right. So for you to do that, you're just going to say, give me the values of whatever that is, give me the values of anything else that is the complement of A. That's what I want you to start with, the complement of A. The complement of A, remember, we are talking about what? We are talking about something that has nothing to do with A. So this value here, this has something to do with A. We're not going to deal with that. And this value here, it has something to do with A, so we're not going to deal with that. But this one here, it has nothing to do with A. And this value here also has nothing to do with A. So I'll use those 2 values. So I have here 0.2 and 0.3. Those are the values that have nothing to do with A. After that, I look for the probability of B. So the probability of B, I'm saying to you that give me anything that has to do with B. So now in this case, I have this value right here. Let me highlight that. I have this value right here. It has something to do with B. And I have this value right here on the intersection. It has something to do with E. But then because I said now I'm working with the union, even if this intersection has something to do with A, but because it's the union, I'm going to count it. Because as long as it has something to do with B. So I'm going to count the union because it has something to do with B, even though I'm looking for something that has nothing to do with A. So now let's move on. So the values that I have there, select the pencil. The values that I have then, I have 0.1 because it has something to do with B. I have 0.3 because it has something to do with B. How nice is that? Now, the answer for me there, it's this whole thing here. I'm looking for the union, but I must be mindful that something that appears once, I don't count it twice. So here I have a 0.3. Also here I have a 0.3. So I'm going to remove one of those so I don't count that thing twice. Now, my answer for the question that they wanted, I have probability of A, the complement of A union B. The answer to that is 0.2, which is this one, plus 0.3, which is this one, plus 0.1, which is this one. And the final answer for that is going to be 0.6. That's how you answer that. Let me erase this now so I can bring in something else. So here I've written the next question. It says, give me the probability of A and, look at that, that's the intersection, and the complement of B, right? So now let's do that. Let's see what we can do with it. So I'm looking for the probability of A. So I'll highlight all values that have something to do with A. So this 0.4 has something to do with A. I'll write that one down. And this 0.1 has something to do with A. So I'll also write that one down. Let me write them down. Let me remove this. So I have 0.4 and I also have 0.1 right there. Those are values that are the probabilities of A. And the next thing that I'm looking for, it's the complement of A. The complement of B. Anything that has nothing to do with B, right? So now let's highlight that. I'm looking at now, this has something to do with B, so I'll leave that alone. This has something to do with B, so I'll leave that alone. So now I'll look at this value and I'll look at this value, because this value outside, it exists, guys, and it has nothing to do with B. And at this current moment, that's what I want too. So I'll write down 0.4 and 0.2. Now let me remove this. 0.4 and 0.2. 0.4 and 0.2. Now my answer to this question, I'll find it here on these values that I've just written down here. My answer to this question, because I'm looking for an intersection, I'm looking for this, an intersection. In this case now, I'll no longer add these values together like before. I'll have to choose values that are common, and that is the intersection that they are looking for. So this is the intersection that they are looking for. So now my answer to that question is going to be, in this case, the probability of A intersecting with what's not B is equals to 0.4. That's how you do it. Please don't stress yourself over these things. Keep them as simple as possible. Now, if you didn't understand these examples, please go back, try them again, and see if you can understand them. Like, look at them again and see if you can understand them. But now I have to move on. Let's go on to the next part. My notes. I have a lot of notes. So here we have these items here. In this case, they are saying the probability questions using Venn diagrams. The shaded region represent the events. So now I have to write the answers that fit this narrative in this case. So the shaded regions, those are our probability regions. Let's see if we can annotate the right values to these events. So here's the first one. The first thing I see there is that obviously here I'm working with A. So I'll say this is the probability of A. Right? This thing, it's not working properly. Let me erase that a bit. Let me use the thing is, at this point. So yeah, here, as I was saying, we are looking at this event here. Obviously, we can see that it has something to do with A. So I'm going to say there this, it's the probability of A. But look at that. The intersection was not highlighted, which means it has nothing to do with B, right? Right? So, if the intersection was not highlighted, remember here. Let me take you back. Remember at this part, we said whenever you are working with the union, you can highlight the intersection. But whenever you're working with the end, you never highlight the intersection. So same thing goes here. Because the intersection was not highlighted, it means now I'm working with end. Right? And then what else was not highlighted there? Well, B was not highlighted. That only makes sense that they wanted to highlight something that has nothing to do with B. So this is how it works. They've highlighted A, here is A, and they didn't highlight, they wanted to highlight something that has nothing to do with B. So places that have nothing to do with B, it's the empty space, and it's also A. But the intersection, it's where? It's only at A. Simply like that. Next one. Here, what is not highlighted? You start there because a lot of areas are highlighted there. So I'm just going to start by saying something that is not highlighted here, it's B. So which means my answer in this case is the complement of B. Anything not B related, it's highlighted. And then I look at the center. Is the center shaded? Yes, it's shaded. Which means which symbol are they using? They're using the union. Right? And what else is highlighted? Anything that has to do with A. So that's my answer right there. Next one, here I have this one. So there's only one small area there that is not shaded, and that small area, it's so specific. That area, it's called the intersection of the two events. So can I say the probability of the two events is shaded? No, it's not. So which means whatever that is shaded is the complement of that intersection. Is that fine? Moving on, here I have this one here. This actually is like this one right here. Just events being switched around. So which means now the probability that I have here, already I can see that B was shaded, and I can see that the intersection right there, it was not shaded, which means is my symbol a union or an intersection? It's obviously an intersection. And then was A shaded? No, A was not shaded. So which means they wanted to shade something that has nothing to do with A. So places that have nothing to do with A is B and the rest of the sample space. But what they wanted was the intersection. So which means I'm looking for B intersecting with what is not A, and the only place where they intersect is right there. Moving on. Here I have this two probability events. And these two probability events, a lot of the area that is not A, it has been shaded. So I'm going to say not A, or the complement of A has been shaded, right? And then again, I look at the intersection. Here's an intersection. Was it shaded or not? Yes, it was shaded, which means I'll use the union, right? And what else has been shaded then? Was B shaded? Yes, B was shaded. So I'm going to say event B was also shaded. So what is shaded is anything that has nothing to do with A, and what is shaded, it's anything that is B. And because it's a union, I'm going to shade everything else that is like that. So the probability here. So there is something specific here. There is something nice about this diagram. What you see is that the rest of the sample space was shaded, but A was not shaded. Anything that has to do with A was not shaded. Let me do it this way. I think I have a nice way to say it. So I'm saying here now that A was not shaded. So I'm going to put a complement there. That's something that had to do with A was not shaded. So which means this area and this area were not shaded. Let me remove this small X marking there. Perfect. Yeah. So anything that has to do with A was not shaded. What else was not shaded? It was something that has to do with B. Right. So now I'm saying the union there and B there and this. I'm saying if anything is A, we don't shade it. If anything is B, we don't shade it. Is that fine? I hope it's perfect. And I'm going to say the probability of that. So whatever that is A, we don't shade it. Whatever that's B, we don't shade it. Easy as that. We shade the rest of the area, but that. So that is that. In case you don't understand, please rewind the video and go look at these things again now. So we can try to move on now. We want to talk about the summary of the 2 rules of probability. So in probability, guys, please make sure you understand this first 2 parts first, and then you can move on to this one. And when you do now, we are talking about the rules of probability. So there's a formula that we use for calculating probability. So there's a formula for calculating the union. Remember when they say or, this area here, this is the union, right? And the symbol that is associated with that, it's a U. And there's a formula for calculating the intersection. And the symbol associated with that is N. Easy as that. Now, these 2 formulae, what happens is that if you have one formula, the other one represents the other. How do we mean by that? If you've done algebra in term 1 this year, you are going to realize that through additive inverses, either this it's on this side and this it's on this side, and you have a formula like the one here at the beginning, or vice versa. You see that? So they just take this portion, this one here, place it on the other side if they want to find the union. And they can take this one here, place it to the other side if they want to find the intersection. Just that. But just cram the 2 formulae. Make sure you know them at all times. And the other formula that we have is this one. This beautiful formula right there. This formula works with an event and it works with a complement. Now, here when they say the probability of not A, we are talking about the complement. If I'm looking for the complement of A, I'm going to say 1 minus the probability of A. So which means if I want the complement of A, but I already have A, then I can find the complement of A. And this other formula right there, this one here, it's if I have the complement of A, but I'm looking for the probability of A, then I can use this formula. You just have to remember that it's 1 minus the other for you to find what you are looking for. Now, here is this question right here. These are the type of questions you'll get. And once you get questions like this one, you have to remember what's needed. If ever you need to draw a Venn diagram to make things easier for yourself, just go to the Venn diagram. Right. So here, we have this item here. They're saying that the probability of A, let me choose this thing to point with so that you can see. They're saying that the probability of A is 0.7. The probability of B is 0.5. The probability of the intersection of A and B is 0.4. You see what we have there? We already have everything. So now, the first question there, right off the bat, they're saying, give us the probability of the union. Now, what do we do? What do we do there? We use the formula that says the probability of the union, is equal to the probability of A plus the probability of B minus the probability of the intersection, or intersection, it's N, not U. Sorry for that. Yeah, there we go. And then from there you substitute. Remember algebra, guys. I'm sure all of you now, you know how to solve algebraic equations or expressions. So what is this one now? The union. Do we have a value for that? No, that's what we are looking for. So I'm going to say now the probability of the union is equals to, do we have the probability of A? Definitely. Here is the probability of A, 0.7. So that's 0.7 plus, do we have the probability of B? Yes, we have 0.5 for the probability of B. So plus 0.5 minus probability of the intersection. Do we have a value for the intersection? Most definitely. Here's the probability of the intersection, 0.4. Right there. And by that, what are you going to have? You're going to have the probability of the union is going to be 0.4 plus 0.5. How much is that? That's 1.2. 1.2 minus 0.4, that's 0.8. Oh, guys, please use a calculator for that. Ne? There are people who are allergic to calculators. So let me put out my calculator then. Because people do mistakes, and when they see the teacher not using a calculator, they try to not use the calculator too, which is some logic I don't understand. So let me do that for you. 0.7 plus 0.5 minus 0.4. Here we go. That's press SD 0.8, which is the answer that we got here. Be good. So now I would advise you though to draw a Venn diagram. Let me quickly draw a Venn diagram here to quickly save your time. Let me draw it. So here's a very nice Venn diagram right there. And so we are going to try to fit in some details that we have there. Don't force things, guys. You only allocate what you have. You only work with what you have. And if there's something you don't have, see if you can find it. If you can't, it's still fine. Don't force things. So here they give us the probability value that was 0.7, which is not the true value. We are still going to work with this one. The probability of A right there, guys. In case you don't know what I'm talking about. The probability of A is 0.7. Then they give us the probability of B right there. They said it's 0.5. So I'll go to my Venn diagram there and write 0.5, which is not final. Because as you can see now, already the probability of A and the probability of B, they are over 1. And probability values are only supposed to add up to 1. And then they gave me an intersection. They said the intersection is 0.4. So I'm going to come here and say, okay, 0.4 right there. Now, after that, what I want to do is to take the 0.4 and subtract it from A and also subtract it from B. Because this 0.4 now it's counted 3 times. It's counted here in A, it's counted here in B, and it's counted here in the intersection. So I'm going to say 0.7 minus 0.4. I'll get a new value. How much is that? 0.3. And then here I'm going to say 0.5 minus 0.4. How much do I get then? I get 0.2. So these are the values now of my events on the Venn diagram. And then I'm going to say now, I can see that A is 0.3, the intersection is 0.4, and B is 0.2. And when you use your calculator there to figure out how much does that add up to, you have 0.3 plus 0.4 plus 0.2. That gives you 0.9. So there's a value missing there for us to get up to 1. That value missing, how much is it? Obviously it's 0.1. You can use a calculator for that just to check your answer, guys. Please avoid making mistakes. So the value that's missing there is 0.1. Where will that value fit? Because now we already have a value for A, a value for the intersection, and a value for B. That value now, it will fit right here on the sample space, 0.1, so that the whole Venn diagram adds up to 1. Right. Now, when I say now, give me the probability of A or B, I'm going to say now that the probability of, let me write it down. The probability of A union B is equals to, wait. Look at that. We said here we had, oh, my bad, guys. My bad, guys. So here we had, let me fix that one quickly. I hope you'll forgive me, guys. I won't edit this part out. You'll see it in the video. So we said here we had 0.5. So 0.5, when we minus 0.4, we are left with 0.1 there. I won't edit this part out, you'll see it on the video. So yeah, when we subtracted the intersections, here's the intersection, the 0.4. When you subtract 0.4 from 0.5, we actually get 0.1, right? So which means now in the sample space, in the rest of the sample space, we are going to say 0.3, 0.4, that's 0.7, plus 0.1, that's 0.8. So which means in the rest of the sample space, I'll be left with 0.2. Probably there are some people who have figured that one out already. But if you got confused, I'm sorry for that. But I'm not going to cut this part out. I don't edit my videos, guys. Sorry for that. Yeah, so here now, when we are looking for this one, the probability of the union, we are going to add anything that has to do with A, the intersection, and B. So that is 0.3 plus 0.4 plus 0.1. So now the probability of the union is going to be 0.8 as we found it here. So you can use a Venn diagram for you to find the values they are looking for. You can solve anything with your Venn diagram, or you can just use the formula to solve your answer. So you're spoiled with options, right? So I hope you're good there. Let me erase some things there to create some space and see if we can work again. So guys, in this probability questions, this is one part where you must collect marks, guys. This thing is so easy. It's so easy. Unlike in term 1 and term 2 where you had algebra, you had things like factorization, Yeah, let's move on. So here we are looking for the probability of the complement of A. The formula says if I am looking for the complement of A, I must use 1 and subtract the probability of A. That's what it says. Now, the answer to that, it's straightforward. I'm going to say 1 minus the probability of A. What is the probability of A? They told me that the probability of A is 0.7. So I'm going to say minus 0.7. And how much is that? It's 0.3. We all good? So I hope you're good. Oh, also, you can also still use a Venn diagram. I must show you multiple ways to do this, guys. We also have a Venn diagram. Take this one here on the Venn diagram. It says 0.3. 0.3, it has something to do with A, so we are not looking for that. 0.4 has something to do with that, so we are not looking for that. But 0.1 and 0.2, 0.1 it's B, so it has nothing to do with A. 0.2 it's the rest of the sample space, which has nothing to do with A. So that is it. When you add 0.1 and 0.2, you get the 0.3 here, which is how we found it also, which is what we found also using the formula. So now, continue with the last question on this part. They are looking for this one. For this one, they are looking for the probability. Oh no, can't use a gray thing here. It won't be visible. Let's hope this one is visible. Is this visible? Still gray. Sorry. Let me use this one. It's more nice, I think. So we are looking for the probability of not A or B. So we have A or B, but because of that not it's outside the bracket, we're going to place the prime outside the brackets. Right. So you already have this one here. Look at that. The probability of A or B. The formula says, it says, if ever I'm looking for the probability of the complement, I can say 1 minus the probability of what is not the complement. Like that. We good? So now for me to find the value of the complement, I substitute here. What was not the complement? What is the value of the union? The value of the union is 0.8. So now, which means 1 minus the 0.8 is 0.2. And that's how you find it. Easy as that. I mean, like, come on, guys. And then if you want to use a Venn diagram for that, just come here and say, they are looking for what has nothing to, they are looking for what has nothing to do with A or what and also what has nothing to do with B, right? So 0.3, it's A related. 0.4, it's A and B related. So there is A, there is B there. 0.1, it's B related. What else is not related? So what is not related to A or B? It's this 0.2 chilling outside there. So that's why my answer is 0.2. So a Venn diagram can also help you do that easily. So let's move on, guys. We have a lot to cover today. Let's move on. So here's another question here. On this question, let's quickly solve it. It says you have the complement of A, 0.25. You have the union of A and B, 0.8. You have the intersection, 0.15. Easy as that. Now, they are looking for the probability of A. How do we find the probability of A? Just go to the formula, guys. The formula says, if I'm looking for the probability of A, I can just say minus the probability of the complement. Do I have the complement? Yes. So now I can say the probability of A is equals to 1 minus, what is the complement of A? 0.25. Then the probability of A will be to me 0.75. Oops. I must use a calculator for that, because there are people who are not going to use a calculator there, and they'll make mistakes like I did. 0.75. There you go. You see that? Please use a calculator, guys. Avoid making mistakes. So now moving on, we are looking for now the probability of B. The probability of B, I can easily use a formula there, another formula. We are spoiled with formulae, guys. I can always use any other formula. Let me use this color here. So I can say, for me, because I have the intersection and I have the union, there's a formula that has an intersection, a union, and the probability of A. So let me use that. The formula says the probability of the union is equals to the probability of A plus the probability of B minus the probability of the intersection. This way. Right? So what is the value for the union? That's R, right? We have 0.8 there, which is equals to, do I have the probability of A? Yes, I just found it in the previous question. Plus, do I have the probability of B? No, that's what I'm looking for. Minus the probability of the intersection. Do I have the probability of the intersection? Yes. How much is that? 0.15. 0.15. Easy as that. And now, on the left side, I have 0.8 is equals to the 0.5 and the negative 0.15. Those are like terms. We add them together, but of course I'll use my calculator to avoid making mistakes. 0.75 minus 0.15. How much do I get there? Press SD, 0.6. So in this side I have the probability of B plus 0.6, because we take the sign of a bigger number. So and then I transpose this value to the other side. I have 0.8 minus 0.6. That must be equal to the probability of B. Now, which means now the probability of B is equals to how much? 0.2. Question answer. Now, the disadvantage, you can still use a Venn diagram here. I'm just saving time now because this video is taking too long. The disadvantage of using a Venn diagram is that if I give you a question like this and then I say for 3 marks, give me the probability of B, a Venn diagram doesn't have the steps that helps us see how did you find that value. So you might find the value of the probability of B, but at best that might earn you just 1 mark. And if this question is out of 4 marks, it means now you need to know the calculations for you to obtain all the marks that you can get there. We all set? Great. So, next question. Next question, it says here, let me choose a different pen so we can see the difference. We are looking for the probability of what is A intersecting with the probability of the complement of B. Easy as that. So now, what are we going to do there? We are going to say here, suppose I have a this shape here, right there, right? And then I've worked out the probability of A right there. And I've worked out the probability of B right there, like that. So let me notate things. Where is this? Let me notate that here I have A, and then here I have B, and here I have the intersections. All right. So what is the probability of A? Let's start with the intersection. I found out that the probability of the intersection is 0.15, right? And then what is the probability of A? I found out that the probability of A is 0.75. So 0.75 minus the intersection, I get how much? Safety first. I use my calculator right there, and I'm going to say 0.75 minus 0.15, and then I get how much there? 0.6. So which means my value for A is 0.6 right there. And then for me to find the probability of B, I'm going to do the same thing. How much did I have for B? I actually had 0.2. So I'm going to say 0.2 minus 0.15. How much do I get for that? Please use a calculator there. Let's just use a calculator. 0.2 minus 0.15. What is that? 0.05. So I have 0.05 right there. So which means here, sorry for that guys, my calculator is acting up. So which means now the probability of B is 0.05, right? And the value in the sample space now, how much is that? I have 0.6, I have 0.15. Let's go back that calculator again, guys. Here we go. Oopsie. Let's see, where is it? Here are the notes. So here it goes. It says 0.2. Let's put it right here so you can see it. 0.2. Oh, no. We are adding all the values. 0.6 plus 0.15 plus 0.05. Oh, we are adding this value. We are adding this value, and we are adding that value. We see how much that gets us. It gets us to 0.8. So these values, they don't add up to 1, but we must make sure that they add up to 1. Now, which means we are going to put 0.2 on the rest of the sample space, because that's what it means. Then erase that. We want to answer the question. Now, we haven't answered the question. And this question, so far, we've answered it with the Venn diagram. So it's best I also do it to you with the Venn diagram. Now, what did the question want? What did the question want? They wanted us to say we want something that we want what has to do with A, right? And let me write it here. There's not enough space here. It said we want what has to do with A and the intersection. Look at that. We are working with the intersection, which means we don't shade this part. So this takes you back to which activity? This one right there. You must master this one for you to answer questions like this one. So now the probability of the complement of B, right? So what has to do with A? This value right here looks like it has something to do with A, so I write 0.6 right there. What else has to do with A? This value of the intersection looks like it has something to do with A, so I'll write 0.15 right then. That's all that has to do with A, right? And the complement of B, this 0.5 looks like it has something to do with B, so I'm not going to use that. This 0.05, same thing. But this 0.6, it has nothing to do with B, so I'm going to write 0.6 there. What else has nothing to do with B? The rest of the sample space, that's 0.2, so 0.2. But then because I'm looking for the intersection of these two events, the intersection is only here because these are the values they have in common. So the answer for what they asked me here is that the probability of what is A intersecting with what is not B, my answer to that is 0.6. That's how you answer questions like that. Venn diagrams, guys. Venn diagrams. Welcome to grade 10. So the last question they are looking for here is the last question. Please don't look at this word mutually exclusive. This topic is rushing into things now. So here, the probability of what is not A. The probability of what is not A, or so here we have the union. The union. So what is not A? We go back to the very same Venn diagram. What is not A is this value here and that value right there, the 0.05 and the 0.2. So I'm going to say 0.05 and 0.2. Let me highlight that so you don't get confused with these things, because now we have a lot of figures here in the diagram. 0.05 and 0.2. So here 0.2 and 0.05. Those are all the values that have nothing to do with A. What else am I looking for? I'm also looking for the probability of anything that has to do with B, right? So what has to do with B? What has to do with B? It's this value right here. This value, we already shaded it. It has something to do with B. Also this one, it has something to do with B. So I'm going to write that one down. Oopsie. 0.05 has something to do with B. 0.15 has something to do with B. Let me highlight those things again so that you may see them. So now, to answer that question now, I'm going to use whatever that I have here. Whatever that I have here is what I'm going to use to answer the question. So because I'm looking for the union, since they said R, or I'm going to add all the values, but I don't count the same number twice. So the answer to that is that the probability of the complement of A union B is equals to 0.5. So here's 0.05, sorry, plus the 0.2. So I'm saying 0.2 plus 0.5. I already counted that, so I'm going to skip that one. Plus the 0.0 plus the 0.15. 0.15. Now the answer to that is how much? I'll show you quick. Remember, you must pull out your calculator, guys. Don't try to do things on your own, because you mostly do mistakes when you do this. Right there, 0.4. So the answer to that is 0.4. Here we go. 0.4. It's a little bit messy here on the diagram, but at least we are moving away from that. And then heading towards the ending part of this lesson, I'm hoping that I can finish this video in less than an hour. The ending part of the lesson is that I want to talk about mutually exclusive events. So when we talk about mutually exclusive events, what are those? You see this empty space here, right there. The circles are not joining. Any event whereby there's no such thing as A and B coming together or happening at the same time, that's a mutually exclusive event, right? So there's no intersection between event A and event B. So we are saying that event A and event B, they cannot occur at the same time, simultaneously. So now, which means there's no intersection. If I ask you for a set notation of an event that is mutually exclusive, you're going to say you're going to say event A and event B, they actually have an empty set. Look, then the first person to be able to write curly brackets, or you can say the intersection of event A and event B is an empty set, like that. You know what's an empty set, right? I'm sure you know that, right? And when I'm asking you now, the probability that I can get an event that is an intersection of A and B, what is the probability of that? 0. There's no such thing. There's no way you can get the intersection of event A and B. So your Venn diagram is these two circles that are separate. It's this circle and this one. They don't join because they have no intersection. Those are mutually exclusive events. And we have exhaustive events. Now look at these two diagrams here. in these two diagrams, exhaustive events, we are saying, usually we used to have Venn diagrams whereby, let me show you here, if there's a clean Venn diagram. Oh yes, right there. So you see this Venn diagram right here. This Venn diagram, it says to us, if I add this value, and I add this one, and I add this one, and I add this one, I get 1, a whole, right? But when we talk about exhaustive events, they don't need this value to add up to 1. Like this one, they don't need this value for them to be able to add up to 1. Anything that has to do with event A and event B by themselves, these values, they'll eventually add up to 1 without needing the rest of the sample space. Let me show you here. Let's go back there where I just highlighted those things. Right there. You see here, we have 0.4, we have 0.4, and we have 0.6. When you add up 0.4 and 0.6, you actually get 1. So they don't need the rest of the sample space for them to add up to 1. Event A and B by themselves, they add up to 1. Let's look at this one too. When you take 0.1, you add to 0.3, you get how much? 0.4. And you add this one also, you get how much? 1 as a whole. So we call this exhaustive events. That A, it's actually the complement of B, and B is the complement of A. Like, look at this one here. This one here, whereby the complement of A is B, the complement of B is A. These are exhaustive events in this case. The statement that I said before, it doesn't apply in this, it applies to the next one. Sorry for that. Yeah, but yeah. So here, they don't need the rest of this sample space for them to add up to 1. So we call these events exhaustive events. What else do we have? The main idea is to get up to here. Now, those two statements, when we combine them, the exhaustive events and the mutually exclusive event. Let me use green here purposefully. Let me intentionally use green here. Right there. So I'm saying an exhaustive event, when I add it with a mutually exclusive event, I must actually get a complementary event. Right there. What is that? First of all, a mutually exclusive event, their circles, they don't add up here. There's no intersection. That's a mutually exclusive event. And then what is an exhaustive event? An exhaustive event it's an event. It's an event. Not it. It's an event whereby if I take this value, I add it up with this value, I must get 1, a whole. Right? So that's how it is. Now moving on, let's take on some 2 questions before you get tired. Just these 2 questions whereby we answer this question. We answer anything related to mutually exclusive events and things like that. So here, look at that. Here's a question. It says A and B are mutually exclusive events such that event A is 0.25. Event of the complement of B is 0.58. Determine the union. Oh, look at that. This is so beautiful. Oh, I wish I can take this moment and pause and just appreciate how nice this question is. Look at that. For this word, remember in maths, once you see a statement, put it in numbers. Mutually exclusive. Mutually exclusive says what? It says to me that the probability of the intersection of A and B is 0. That. Right? That's what the statement says. Now, which means if I found the probability of A, I have the probability of... Guys, like I have everything here. Like look at this one too. Look at this one. I'm so excited talking about these things. Maths is nice, guys. Now, look at this one here. Look at this. I have the complement. And if I have the complement, it means I also have the event using the formula. So now I can just say here, since this is the complement, I can say now the probability of B is 1 minus the probability of the complement, like that. And then now I can just substitute there and solve for that. I'm going to say 1 minus, how much is the complement? 0.58. Now, you use your calculator there to avoid making mistakes. You just say 1 minus 0.58. It was 0.58, right? Let me see that. Yeah. How much do I get for that? Press SD. 0.42. So I'm just going to say here 0.42. That's the value of the event, the probability of the event B. Here we go, right there. You see that? Now I can answer their question. I can answer their question. I have the intersection. I have A. I have B. There's a formula that accommodates for those kind of things. So what am I looking for? I'm looking for the union. So I'm going to say the probability of this is equals to the probability of this plus the probability of this minus the probability of the intersection right there. I have everything. So I can just say here now the probability of the union is equals to, what is the probability of A? Here's the probability of A, 0.25. So I have 0.25 plus the probability of B. Do I have the probability of B? No, I had the complement. I used the complement to find the probability of B. So I'm going to say plus 0.42 there, 0.42. And do I have the intersection? Yes. When they told me that something is mutually exclusive, I know actually that the intersection is 0. So minus 0 there, right? Then I can say now that the probability of the union is equals to 0.25 plus 0.42. So I'm going to say 0.25 plus 0.42 right there. Press SD right there. You get how much? 0.67. So my answer there is 0.67. Was it 0.67? I think I just said that number, but I didn't see it. Oh yeah, 0.67. Easy as that. Let's get to the next one. I think I'm boiling. I think this lesson won't take 1 hour, but then let's see. Yes, this teaching thing, something else. Right there. Let's move this thing properly because it's becoming stubborn now. Yeah. So here is this question right there. First, we read to understand. Events C and D are mutually exclusive. Again, they are blessing us with that statement. When they are saying things are mutually exclusive, they're actually saying to you, just know that the probability of C and D is equals to 0. Take a statement, put it in a mathematical notation, right? And then they gave us this statement, this part of the statement. Now they're saying, just know that the probability of not C is 0.3. What does that mean? It says to you, since you have the probability of the complement, you can actually use the complement to find the probability of the real thing, right? You just have to say the probability of C minus, it's equals to 1 minus the probability of the complement. Now, which means now the probability of C is equals to 1 minus, what is the value of the complement? 0.3. How much do we get there? We get 0.7. Sorry that I didn't use a calculator there. What else did they give you? They gave you this one here. They said to you now that the probability of the union, let me highlight that. The probability of the union is 0.8. Oh, that was violent in this highlighter. So, is there a formula that ever needs me to use the probability of C and the probability of the intersection and the probability of the union for me to find the probability of D? Most definitely. I just have to say now that the probability of C, this is C, let's do it properly. The probability of C intersecting with D is equal to the probability of C plus the probability of D minus the probability of C or D, that way, right? Now, we said how much is the intersection again? Mutually exclusive, it's 0. Is equals to, what is the probability of C? I just found it here, 0.7. So 0.7 plus the probability of D is what we are looking for, minus the probability of the union. That violent highlighter there, where is it? Here. We have 0.8. Right. So and then now additive inverses, like terms and things like that, we solve for that. So on the left side, I still have 0 is equals to this and that are like terms, right? So I have 0.7 minus 0.8, that's probability of D minus 0.1, right? Yes. And then now I transpose, there's no such thing as a negative probability, by the way. So the probability of D is equals to, you send this to the other side, it becomes positive 0.1. Therefore, the probability of D is equals to 0.1. Easy as that. Guys, I was hoping that this video will take 1 hour. It actually took more than an hour with an extra minute. But I very much appreciate your patience. If you watched this video up until here, please subscribe, like the video, share the video, all those nice things. And I hope to see you on the next one. Goodbye, great friends.